So good evening everyone. So in this video we are going to discussing about the module 4 or unit 4 nuclear chemistry. Okay, so here what nuclear chemistry is a branch of chemistry where we are going to deal with the structure and the properties are the different models which are based on nucleus. Okay, so here in the nuclear chemistry we are basically studying about the nucleus. Okay, so here the important phenomena what we are going to discuss in this nuclear chemistry is the radioactivity. Okay, so this Antonio Henri Becquerel, so he was a French Nobel laureate. Okay, so he discovered what the evidence of this radioactivity. So here in this nuclear chemistry module we are going to discussing about the radioactivity also. Okay, since it is very important and it is a great contribution from our Nobel laureate, that is Antonio Henri Becquerel. So here we are going to find the application of this radioactivity in many different fields. Okay, so that we are going to discuss in this module. So radioactivity is defined as what? The emission of particles and the radio electromagnetic rays from the nucleus of an unstable atom. When an atom is unstable state, it will undergo spontaneous disintegration to emit what? The particles and electromagnetic rays. So this process we call it as what? Radioactivity. So here we are going to discuss the name itself. The module name itself indicate that it is nuclear chemistry, so that here we need to discussing about nucleus. So what do you mean by nucleus? What is the composition of that and all we are going to discuss now. So the nucleus is composed of the nucleons. So the nucleons, so the particle which are present inside the nucleus togetherly we call it as what? Nucleon. So inside the nucleus there are many protons and the neutrons. So protons and neutrons togetherly we call them as nucleons. Okay, a nucleus is characterized by what? Two numbers. One is what? Atomic mass number, and another one is atomic number. Atomic mass number is represented by A, that is capital A, and atomic number is represented by capital Z. Okay, so this atomic number is give you the total number of total nucleons. So that means total number of protons and the neutrons, whereas this Z atomic number gives you the total number of protons or electrons, since the number of protons is equals to number of electrons in any nuclei. Okay, so here this is how we represent any atom, any element and its atomic number and the atomic mass number. Okay, atomic number we are written at the subscript, and atomic mass number is written as superscript. Okay, and E represent, it may be the any nucleus or an element. So let us consider the example here, that is aluminium 1327. So where aluminium is an element, the nucleus, so here the total number of protons is 13, so that is Z, and the total number of electrons is also 13, and the total number of protons is 13, so the total number of neutrons is what? 27, that is A minus Z. Okay, A minus Z. A is atomic A is what? Atomic mass number, so 27, atomic number is 13. So when you subtract 27, sorry, one second. When you subtract this 13 from 27, you will get what? 14. So this is what? The number of neutrons which are present in the given aluminium nucleus. Okay, so here what? 27 is the atomic mass number and 13 is atomic number, and the number of neutrons is 14. So in order to get the number of neutron, usually we represent it as N. N is equals to what? A minus Z or A minus P. So Z is number of protons or new electrons, or P is number of protons. Okay, so A is equals to Z plus P, Z plus N you can take, or P plus N. Okay, so don't get confused. So Z andre atomic number, P number of protons, N number of neutrons. When you add proton number with the neutron number, you will get what? Atomic mass number. In order to determine the neutron number, here you have to subtract proton number from what? Atomic mass number. A minus Z, you will get what? N. N is what? The total number of neutrons. So here what? So the atoms with the particles which are present in the atom are in the nucleus, so that we called it as what? In the atom, usually that is called as what? Subatomic particle. The particles which are present in the nucleus is nucleons. Okay, so there only we will consider proton and neutron. There is no electron part here. So but in subatomic particle, the atom which is made up of different or many three different particles, mainly proton, neutrons and electrons. So these three togetherly we call it as subatomic particles. Okay, so here the subatomic particles, we usually atomic mass unit is represented in AMU. So that is 1 atomic mass unit. Okay, so this mass is represented in AMU, and you already studied this in class 12. So atomic mass unit andre ಏನು 1/12th of mass of carbon 12 atom. ಸೊ ಕಾರ್ಬನ್ 12 ಅಲ್ಲಿರೋ 12 ಪಾರ್ಟ್ಸ್ ಏನಿರುತ್ತೆ, ಸೊ ಅದರಲ್ಲಿ ಒಂದು ಪಾರ್ಟ್ನ ಮಾಸನ್ನು ನಾವಿಲ್ಲೇನಂತ ಕರಿತೀವಿ? ಅಟಾಮಿಕ್ ಮಾಸ್ ಯೂನಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಆಸ್ ವಾಟ್? ದ reference. Okay, so this is how we are going to measure the mass of different particles. So subatomic particles, I already said there are 3 subatomic particle. One is electron, proton and the neutron. So what is the mass of the electron? 9.11 into 10 power minus 31 kg, and proton is 1.673 into 10 power minus 27 kg, and neutron is 1.675 into 10 power minus 27 kg. So the the mass of proton is almost equivalent to what? Neutron. So here this is mass of the subatomic particle. We represented in terms of kg. So if we represent in terms of what? Units, so that is 5.485 into 10 power minus 4, and it is proton is 1.0073, neutron is 1.0087. Okay, so this is what you should know this, because the mass of the electron we are going to use in numericals based on binding energy and Einstein's equation. So there we are going to use this, so therefore you should remember. Okay, so next here in this nuclear chemistry, we are going to deal with some of the important terminologies. Here first is isotope. Isotope you already know, so that the same atom with the same number of proton but different number of what? Neutrons. So if the number of neutron is differing, you can say also this in another word, that atomic number is same but the atomic mass number is different. Okay, so then only you can get the different in number of neutrons. Okay, so here you can explain this in 2 ways. One is based on proton and neutron number, second one is based on atomic number and the mass number. Okay, so here atomic number is same, mass number is different, then it is isotope. Okay, here you can say hydrogen. So here hydrogen is an atom which has only 1 electron. Okay, when this hydrogen which is in deuterium state, okay, so deuterium state, so there that we are going to usually represent it as H2. Okay, so this hydrogen is H1 and deuterium is H2, and the tritium is H3. Okay, so here what happened? The electron number is fixed, that is atomic number is fixed, but only the mass number is changes, so that is increased by 1. So that means here in case of H1, so there is no neutron, but here in case of H2 there is 1 neutron. Here in case of H3 there are 2 neutrons. So here all are possessing the same proton number, so same electron number, but there is different in number of neutrons. So these type of atoms, nucleides, we called it as what? Isotopes. Okay, so isotope, they has the atoms which has same proton number but different number of neutrons. Next, isobars. Isobars are the atoms of different chemical elements. Okay, so they are different element, they are not the same element, so they are different element but having the equal values for atomic mass but different atomic number. So it is the reverse of isotope. Isotope ಅಂದ್ರೆ ಮಾಸ್ ನಂಬರ್ ಡಿಫ್ರೆಂಟ್ ಇರುತ್ತೆ, ಅಟಾಮಿಕ್ ನಂಬರ್ ಸೇಮ್ ಇರುತ್ತೆ. ಬಟ್ ಐಸೋಬಾರ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಮಾಸ್ ನಂಬರ್ ಸೇಮ್ ಇರುತ್ತೆ, ಅಟಾಮಿಕ್ ನಂಬರ್ ಡಿಫ್ರೆಂಟ್ ಇರುತ್ತೆ. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಆರ್ಗನ್. ಆರ್ಗನ್ is having atomic number 18, mass number is 40. In potassium, mass number is 40, atomic number is 19. Calcium, atomic number is 20, mass number is 40. So when you compare these three, here the mass number is constant, that is 40, only they are differing by the number of protons or the atomic number. Here in case of argon it is 18, in case of potassium it is 19, in case of calcium it is what? 20. So here the isobars are the atom which has same atomic mass number but different atomic number. Okay, so here based on this we have another important terminology, that is mass defect. So what do you mean by this? How can I define this? Okay, so here mass defect is usually represented as what? Delta m. Delta m, small m. Okay, so this is what? The difference between the mass of the nucleons minus mass of the nucleus. So nucleons is what? The total mass of number of protons and the neutrons. So nucleus is in when you weigh the element by mass unit, that atomic mass unit, so then you got some value, that is what? The mass of the nucleus. ಸೊ ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್ ಅಂತ ಹೇಳಿದಾಗ ಪ್ರೋಟಾನ್ ನ್ಯೂಟ್ರಾನ್ ಎರಡನ್ನೂ ಮಾಸನ್ನು ಆ್ಯಡ್ ಮಾಡ್ತೀರಾ. ಸೊ 6 ಪ್ರೋಟಾನ್ ಇದೆಯಾ, 6 ನ್ಯೂಟ್ರಾನ್ ಇದೆಯಾ, 8 ಪ್ರೋಟಾನ್ ಇದೆಯಾ, 8 ನ್ಯೂಟ್ರಾನ್ ಇದೆಯಾ, ಅದೆರಡನ್ನ ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಯು ವಿಲ್ ಗೆಟ್ ಮಾಸ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್. ಅದೇ ಮಾಸ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ ಹೇಳಿದಾಗ ವೆನ್ ಯು ವೇ ದಿಸ್ ಇನ್ ಅಟಾಮಿಕ್ ಮಾಸ್ ಯೂನಿಟ್ ಯು ವಿಲ್ ಗೆಟ್ ವಾಟ್? ದಿಸ್ ಮಾಸ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಬರುತ್ತೆ ಡೈರೆಕ್ಟ್ಲಿ ವಿತೌಟ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ದ ನಂಬರ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಎಷ್ಟಿದೆ ಅನ್ನೋದು ನೋಡಿದೆ. So here what? The mass of the nucleus is slightly less than the mass of the individual nucleon. So nucleon the weight ಅನ್ನು ನೋಡಿದಾಗ ಮಾಸ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಬಂದು ಒಂಚೂರು ಕಡಿಮೆನ ನಾವಿಲ್ಲಿ ನೋಡ್ತಾ ಹೋಗ್ತೀವಿ ಯೂಶ್ವಲಿ. ಸೊ ದಿಸ್ ಡಿಫ್ರೆನ್ಸ್ ಏನಿರುತ್ತಲ್ವಾ, ಸೊ ದಿಸ್ ಮಿಸ್ಸಿಂಗ್ ಮಾಸ್, so where the mass of the nucleus is slightly less, no, so that we call it as what? Mass defect. So mass defect is the difference in mass between the nucleons and the nucleus. So when you take the difference between the mass of the nucleons and the mass of the nucleus, you will get a slight difference in mass, so that mass we called it as what? The difference we called it as what? Mass defect. So here what? In order to determine this, here we are going to making use of this Einstein's equation. So here energy and the mass that can be interconverted. So by the equation E is equals to mc square is one of the well-known equation and well-known contribution from Einstein's. Okay, so here what? When the protons and neutrons, they're packed together to form what? The nucleus. So some of the mass is converted into energy and it is released. So when you compress this, or when these protons and neutrons they are getting to the nucleus, so they are what? The energy is released. So this amount of mass is equals to what? The force of attraction that is holding the nucleons together. Here the protons and neutron that has to be hold, or that has to be present inside the nucleus anta ಹೇಳಿದಾಗ there must be some forces which is required. So here what? So the amount of this mass is equals to what? The force of attraction. Okay, this is explanation was given by the scientist Einstein. So here what? V is equals to mc square. We are going to use this equation. So here binding energy, this is another important terminology. So binding energy, what do you mean by this? Here what? The total energy which is required to break up a nucleus into its constituents, protons and the neutrons. So here how much energy which is required in order to constituent or in order to give your protons and the neutrons. So that here we called it as what? Binding energy. So here the nuclear binding energy is measured in terms of mega electron volt. So this binding energy which is equals to what? Delta mc square. So delta m is what? Mass defect, that is mass of the nucleons minus mass of the nucleus. Okay, and c is the velocity of light, and binding energy you can easily calculate by using this equation, that delta mc square. But while representing this binding energy, you have to measure or you have to represent always in mega electron volt. Okay, so this binding energy is the energy which is required to split a nucleus of an atom into its constituent part. So in the protons and neutrons, or collectively you can call them as nucleons. Here the binding energy of the nuclei is always a positive number. Okay, so since all nuclei require net energy in order to separate them into individual protons and neutrons. So while calculating the while doing any numerical problem, so you have to make sure that whatever the answers you are getting for binding energy, so that should be what? Always positive number, because they need some amount of energy in order to get separate them, in order to get separate as protons and neutrons. So this is what the binding energy curve, where this curve is plotted against binding energy per nucleon versus atomic mass. So when you see this binding energy curve, so here what in this peak, when this graph you can observe, so there is some peak. Okay, so this peak will represent what? The most stable element. Okay, so the graph peaks at what? 56, mass number 56. Mass number 56 is what? Is for iron. Okay, so here as the more binding energy is released per nucleon, so when there will be more binding energy is released, so the nucleus is becoming more stable. Okay, so the mass number of 56 is what? The maximum possible stability. So it is the most stable element. So that is iron. Next is packing fraction. So this is also an important terminology in nuclear chemistry. So the difference of actual isotopic mass and the mass number in terms of what? Packing fraction is defined as, so here actual isotopic mass minus mass number divided by mass number into 10 power 4. For example, if you have considered carbon, hydrogen, nitrogen, their different isotopic atoms are exist. So based on that, you can easily determine the packing fraction by taking the difference between isotopic mass and the mass number. By applying, substituting those values in this equation, you can get the packing fraction. Okay, so this is about the important terminologies in this. And here we have another few important terminologies based on the nuclear stability. Okay, are based on the concept of nucleus. Okay, so that we are going to discuss in next class. So here we are going to discuss very few important terminologies, and they are very direct questions, so they will come very directly. So that means there will no twist, or there is no indirect questions come from this topic. So they will directly ask you define the following terms, isobars, isotopes, like this. They may ask you and explain binding energy, and based on the binding energy per nucleon they will give you a numerical. So that we will do it later. Okay, numerical part we'll do at the end of the module. So now we are going to discussing the important theoretical concept which comes in this module 4. Okay, thank you. We'll continue in the next video.